Welcome everyone to today's live stream here. Some news site reported an OpenSUSE enables LTO link time optimizations by default, smaller and faster binaries, and of course you had me at smaller and faster binaries, so it was time to take a closer look. Actually, I took a closer look already quite a while ago, probably a decade ago when this came out first at GCC or something of that sort, but as far as I remember the results were not that amazing, and this is why, as usual, I had so many other stuff to do, wasn't really worth my time. Anyway, you have seen my huge compiler and stuff benchmark from all the previous videos, I guess. Not only this one, which is all done on the same AMD Ryzen virtual machine here, but also the vast, like in the meantime, maybe 30 systems from SGI Octane to PS3 fame here, as that we compared, and so people get a better understanding where is the SGI Octane transmitter efficient and PS3 and Apple G4 and all this kind of fun. So with this benchmarks in mind, I had people asked already link time optimizations when this video came out the other month, and I quickly wanted to compile it, but it just didn't compile, as so often some small pieces and bits are missing and stuff just didn't compile. So only today I finally took a closer look, and I have some preliminary also results that I wanted to share. So build time here, you see these are all the previous benchmarks, and that you can see if you are interested in all the CLang or Clang or GCC and even new CC, PCC, TCC. Of course, it's a little bit toy compilers, but at least something to compare in terms of super fast build time, if not very feature complete. Anyway, so new today is here's this GCC 902 FLTO run that with a little manual fiddling then eventually produced here some results. And the results are not as amazing as you might have expected, because this article claimed here, as of today, latest blah blah blah, major something kudos, achieving LTO state, getting out some fresh benchmarks or whatsoever, something. And so for end users it should mean faster and smaller binaries, so both would be amazing. So let's take a look first on build time, and yeah, so build time, no surprise there, stuff builds like significantly faster. Small old stuff from decades ago, BSIP2 built here in a second or 2 seconds or 1.5 seconds. Here with link time optimizations, a whopping 3.44 seconds, so no surprise there. But then GNU PG, so yeah, that built in 23 seconds. Yeah, so link time optimization of course means that the compiler like GCC or CLang, they do not directly produce a machine code that is assembled and linked eventually relatively fast, but is producing intermediate information, like not directly the machine code, but internal state of the compiler that is then in a final step, not using a regular linker, but compiler infrastructure linker that is reading all those intermediate representations in, and only then doing final optimizations and whole program optimizations that supposedly generates faster and maybe smaller binaries, but certainly can take a real whopping amount of time longer. So mostly here much longer compile times here, 3 times longer, just like in the beginning, up to here in terms of here 5 to over 4 times longer. Only set standard may have been slightly faster for whatever reasons, maybe if this is not some strange outliner. Anyway, how does this translate to runtime performance? So runtime performance is unfortunately also not as amazing, but again, many of the previous results have been here in the term of measuring accuracy. So LTO here not really faster here, although it is 2 seconds faster for GNU PG. Well, it also took like 4 times faster to longer to compile, right? GSIP also not really faster, and lame a little bit faster. Here's this MP3 encoder libmet also not really faster. What is faster? Again, a little bit, tiny little bit is set standard. 1 second here. And how does this translate? Oops, it was the wrong key. How does this translate to size? We were promised smaller binaries. So on the smaller binary front, yeah, bzip2 a little bit smaller, GNU-PG a little bit smaller, gzip a little bit smaller, lame a little bit smaller, libmet. Yeah, not really whatever happens there, like this, like twice as large, so much to air. That is a problem with all these fancy compile optimizations when you are being promised faster and smaller stuff, like, yeah, sometimes, not always, sometimes it can also double your binary, but set standard again a little bit smaller. So I will most likely experiment a little bit more with this. So first results, it takes significantly longer to compile, usually up to 3-4 times, you name it, which in case of Firefox and Rust and stuff might not be amazing, or I don't even want to know how long Musil, Clang or LLVM compiles with this. And yeah, smaller sometimes, well, of course this is as usual not doing wonders here, not doing miracles. It sometimes is fractions of some percent smaller or faster, but yeah, if you compile this once and run this for hundreds of thousands of users in case of SUSE or Android, this might be worthwhile for people like me, T2, Gen 2, and people compiling this from source. So again, wrong key. If this excessive build time is amazing, not really sure. Maybe something like I proposed this already before, really just-in-time compiling, even C-like programs, just-in-time compiling, because I usually don't even compile with the latest and greatest Zenvert 1, 2, 3 or Core i9, you name it, because I sometimes plug in my portable SSD in other machines and then I would have binaries that simply don't work. So maybe just-in-time compiling C and C++ code would also be amazing. If you have experience with LTO, leave it in the comments below. If you have tried this, what are your stuff? I think here was in the comments, yeah, 25 comments. I think someone commented there, this is why LTO, why he saw here, yeah, oh, that's why so many packages are broken and no need define LTO cflex nil. And yeah, what is the stuff when this doesn't compile? You cannot run the usual AR, archiver or runlib, just like here. So common things, I tried one run here with Clang, with Musil, and you see cannot open shared object, no such file or directory with error loading plugin LLVM Gold, wherever I need to get that from. The fun of running your unsuccessful one-man Linux distribution. But I had a similar issue with bzip2, so we could probably multi-bench if we run this. Is this even on screen? Or it's even on screen for the most part. And if we run this here with multi-bench set standard, with, where is even my focus? So if we change this back to GCC, this is just here more than you would normally G++ benchmark. So let's run just bzip2 because I think this should fail. It's also the wrong directory. And then GCC 02. This will of course not work because we are not in the right directory. So that is OpenBench CPU tests. And if we run this again, yeah, this also needs a full benchmark name that I didn't complete, like that. And this will fail most likely because I hand edited before to compile. There's something fishy with variables. So bzip LTO and bzip2 LTO for that. Maybe not. Why do we have here 2? GCC 02 FLTO. And we have a similar error here because this is trying to run the regular AR archiver plugin needed to handle LTO object, and somehow this makefile didn't accept the passing in a variable for some strange reason. So because there is then also GCC AR and that you would need to run, and also GCC renlib. Not really sure if you can compile bin utils with some plugin handling to handle this transparently. Maybe, maybe not. I tried a moment but didn't just magically work. The fun of this stuff always just works, right? But apparently sometimes not always. Anyway, I will keep this on my to-do list to improve in T2 and do more stuff. I will most likely try to switch and run a C-Lang Musil system, just because, as I said in the introduction, you had me at faster and smaller. And for smaller at least, Musil is a thing. Also, fun fact, there was a Musil release recently, just the other day, that I already updated to. And so I've not yet run this, but I will. Again, this Musil C-Lang was not yet completely amazing. For example, I could not build a Linux kernel or grub2, I guess. That is for another day. But there is a new Musil release. Musil, of course, alternative small C library, standard compliant and quite full-featured, that we already made a couple of videos about for running this. And the latest version here apparently is actively doing, but intended to use on product environment as long as it's pre-tested and what? Anyway, this release not only merges RISC-V 64-bit support, which is amazing, because I was already wondering if I should spend my time on having a custom version of Musil here for RISC-V, which I was not too fond of. Always extra time, but this also has a new math library implementation for log exponent power and internals of how non-cancelable syscalls are performed have been overhauled, so that all code necessary making syscalls resist in an Arch provided header and is inlineable. Is it even on screen? Maybe, mostly, anyway. And yeah, so this sounds of course good. This is inlineable, maybe a couple of performance points there. In this process, bugs in the implementation of MIPS and microblaze syscalls. Syscall mechanism have been found and fixed. Several other bugs were fixed as well. So a bug fix always nice, of course. Potential series ones, layout and static TLS and chat library, and TLS variant 1 layout, and so on. So sounds of course amazing. I've compile tested this and committed this in T2 of course already, because I want here amazing stuff. Here in the changelog you should probably be able to see this here. So Musil, that was yesterday here, or the other day anyway. So yeah, I will continue with this, not only for the Sony Vaio P for 32-bit fame, for the very ultra low voltage, low performance Atom stuff, but maybe even for the Ryzen and OBS live streaming, just to see if we can get this to work. Of course, again, might not just work for all the people who always tell me everything will just build. Not only the LTO stuff does not always entirely just build, but then of course running Qt, OBS and all the other fun stuff like Rust and Firefox. Don't even want to know how much headache that will be to get this compiled. But don't forget to share, like and subscribe for all this fun to come. And if you have any LTO experience, don't forget to leave it in the comments below, because I'm always interested. Sometimes people have tried this already and know that there are special configuration switches to bin utils and stuff like this for transparent LTO plugin handling, maybe. So, and also if you have any performance and stability, code size, whatever numbers, always happy to hear and read what you share there. Comments in the audience. Devi asks Richard Stallman, maybe that's for another live stream, because this is already as usual. If I repeat this stuff 2 times here, then live streams. Leave me in the comments below what exactly you want to hear there, Richard Stallman. I think this was already a question in the other live stream. If there's some latest development, ask me specifically about this, because otherwise I'm busy developing and live streaming and can't follow each gossip of all open source fame. Other comments. Dear thoughts of Void Linux, not really sure what was that. So many Linux distributions, can't know each. I know Alpine and of course Gentoo Arch, you name it. and Intel's Clear, so general purpose Linux based on monolithic. Monolithic, you had me at monolithic, right? Or recurring vaporware. CMIR of allows quick install, update remote software, provided binary packages built directly from source, which help of XBPS source package collection. What is cross? What is it? Cross something BPS. What is XBPS? Not even sure what that is. XBPS service collection built binary void Linux distribution. Yeah, not really heard about this. You see so many thousand Linux distributions. I said this the other live stream. I think, although we have our T2, also again, sharing this work is highly appreciated. Before you start your own, I have no idea how old this is. First time I hear about this one. Of course, I said Gentoo, clearly knows all the other fun stuff, Ubuntu, SUSE, Red Hat, you name it. So many Linux, but not really sure what they try to. Also, there is this new Nix. In my opinion, I would be more interested not only in my microkernel vaporware and stuff. Also, maybe this weekend I will continue with Rendition Verity and Voodoo. Maybe I even run Rendition Verity and Voodoo on the PCIe bridge on an external Thunderbolt enclosure, just for the fun of it. And for sure need to continue my microkernel, because in my opinion all the distributions that are quite similar are not that interesting. I would find it more interesting not only microkernel, but also something like this Nix OS that might have, I've not taken a closer look, but maybe they have a more interesting configuration or something infrastructure. But theoretically we could do more live streams. Also, there is a second channel, my more live stream stuff, that I would theoretically want to live stream more. The reason I'm not doing this yet is because we need 1,000 subscribers to be able to monetize this, because as much as amazing as it is to talk here a whole day, it would be amazing if we would have funding to research all the stuff, not only an alternative graphics stack, but also microkernel and reviewing the stuff. So we could theoretically live stream on the second channel, taking a look at this Void, Clear Linux, or NixOS and this fun stuff. Maybe that is amazing to review and take a look together. But comments in the audience. Specific things. So LTO link time optimizations. The question is, Kevin streamer asked, any specific things that LTO optimizations would increase speed at? So the point of LTO is link time optimization. Normally, if you compile each file, you only run compiler for each file. For example, you have a 3D engine and some whatever model and animation. So you have usually all this many files, hundreds of files. And if you run a compiler on each of those files, the compiler only sees the source code of this one file and only optimizes in this one file. With link time optimizations, the point is that each of those files is only like pre-compiled into an internal compiler specific format, and then when you link this together after this pre-processing, pre-compiling step, the compiler has the chance to see the whole program and can do whole program optimization. So theoretically the compiler can inline more stuff like loops, like algorithms, vector algorithms, image processing, 3D world processing, all this fun stuff. And theoretically this is why whole program link time optimizations has benefits, but as you see, the benefits are sometimes small and compilation time increases 3 times, 4 times, and some stuff even becomes slower. How can it become slower? It can become slower in, for example, stuff is inlined and then the code is duplicated and becomes so huge that although this is a Ryzen, so the caches are actually huge, but nonetheless cache poisoning and other stuff, cache misses, and this is why even if the code size increases vastly, code can also become slower. So all the modern optimizations not only totally amazing, and as always your mileage may vary, so you always especially if you ship this commercially or for whatever reasons, always review if this stuff you are doing even helps, and not benchmark your own stuff. If it doesn't help, then don't ship it, obviously. So you're right, it makes sense that it takes way longer to compile. Well, not necessarily, a little bit. Maybe I'm surprised that some stuff takes so long, but you see worst case scenario, because of course you save time on all those files. You save time because previously a file was parsed and transferred into internal format, tree SSR and all this fun stuff, and then already compiled and assembled. So you save theoretically stuff on each file. So before, maybe each file was compiling 1 second or longer, depending how fancy your code is. So you save a lot of time potentially because it's only transferred into the internal format. So each file could be faster, and then only the final link has all the optimization time. So yeah, I'm slightly surprised that it's like 3 to 4 times faster, slower. But yeah, there you see, you gain something there, you lose something there. More comments make sense. What will try to compile Chromium with crazy settings here. That will. I've not even packaged Chromium for that. I would need to package Chromium. I'm already, yeah, but one day we will do it. Keeping Firefox up to date is already a nightmare, as I documented multiple times on YouTube. And then more comments. The head developer of Void Linux disappeared a while ago, but there's a team got control over the resources again. Okay, interesting. But again, I would be more interested in high performance, state of the art, super stable microkernel stuff, multi-server and stuff. And yeah, thanks for all of you subscribing. We just crossed the 3,300 subscriber mark. That is totally amazing. And the more we grow this channel, the more stuff I've still to finish. The Voodoo texturing, I've also rendition Verity, we have also P3, which is of course here in front of the camera now. I've also auctioned another fun P3 thing that I hope I'm not being ripped off and cheated on eBay. Still hasn't shipped. So I spent a significantly amount of money on some P3 stuff on eBay, so let's hope that arrives next week. Keeps fingers and thumbs crossed. Yeah, so thanks for watching, thanks for joining. Hope to see you soon for all the next videos and live streams to come, and for some miracle reason we have 0 drop frames today. I hope this video therefore was amazing, and I hope to see you soon.